Unit 1 Chemistry, Lesson 3 Ionic Compounds. So yesterday you learned about how ions are formed. So ions are formed when electrons are added to the valence shell or taken away from a valence shell. So now we are going to look at what happens when these ions interact with each other. So an ionic compound is a compound that is formed of ions, and the word compound means two or more elements. So compounds that form between a positive ion and a negative ion constitute an ionic compound. If you'll recall from yesterday's worksheet, metals form positive ions, which means they lose electrons. Non-metals form negative ions, which means they have gained negative charges or electrons. You'll recall that the protons and the neutrons do not move around because they are in the nucleus. So therefore, in order to identify whether it's an ionic compound, you will notice that in terms of its elements formation, there's metals and non-metals that make up the ionic compound. So the ionic compounds are formed when the electrons transfer from one element to another. In the end, the overall charge on the compound should be neutral. So we're going to take a look at the compound that forms between magnesium and fluorine. So the first thing that you need to do is to use your periodic table. You will fill up the shells. So when you look at a periodic table, the atomic number for magnesium is 12, and the atomic number for fluorine is 9. So when you start doing your board diagram, remember that you start with 2 electrons on the first shell. So I'm going to draw my 2 electrons on my magnesium, and then there will be 8 electrons on my second shell, which brings me up to 10. And then I need to get to 12, so there's going to be 1 here and 1 here. So fluorine has 9 electrons. So we start with 2 on the first shell, and then 7 will be on the second shell. So we go up, down, right, left, and I need to add 4 more. So I go up, down, and to the right. So when I take a look at my atoms, I notice that magnesium, in order to form an ion, needs to get rid of 2 electrons. And fluorine, to form an ion, has 1 empty space, so it can only accept 1 electron. So let's say that this electron goes here. So right now I've got magnesium that has lost an electron, fluorine has gained an electron, but I still have this electron that needs a place to go. So in this case, when you need an electron to go somewhere, you have to add another atom of fluorine. So I'm going to add it right over here. So fluorine, first shell has 2, and then the second shell has 9. And so now this electron can go here. So this is a diagram of how the ionic compound will form. So this means that every magnesium atom requires 2 fluorines in order to balance out the charges. So my chemical formula describes the quantity of each element. So I have 1 magnesium, so I write Mg, but I have 2 fluorines. So to show that I have 2 fluorines, I use a little number 2. This is called a subscript. So this tells me that this compound contains 1 magnesium atom and 2 fluorine atoms. The name of this is magnesium. You always start with the name of the metal. So magnesium. And then the name of the nonmetal, you write the first part, and then the ending changes to "ide." So this is called magnesium fluoride. So to get the formula, you don't have to draw it. That's a little bit time consuming. So I'm going to show you another way to get the chemical formulas. So we're going to start with a couple of pairs of elements. So we've got sodium and sulfur. So sodium is our metal, sulfur is our non-metal. So in order to do this, you need a periodic table. So you can use the one that I attached with the lesson, which looks like this. So I'll show you how it works. So you look up where sodium is located in the periodic table, and what you want to do is look at its ionic charge, which is right here. So sodium is in this column here, so it has a charge of 1+. Sulfur, when you look at it on the periodic table, so sulfur is right over here. Sulfur is there. Sorry, technical difficulty here. Sulfur is right here, and it has a charge of 2-. Okay, so 2-. So what I want to do is balance out my charges. So this means sodium can give away 1 electron, sulfur can accept 2 electrons. So in order to balance this out, I need another sodium. So that 1+ and 1+ over here, when I add them together, it's 2+, and it should balance out on the other side with a 2-. So the chemical formula then becomes Na, and I have 2 sodiums, so I put a subscript 2, and I need 1 sulfur with, so the symbol for sulfur is the capital S. To name it, I take the name of my metal and the name of the nonmetal, you take off the ending, and then you add IDE. So this becomes sodium sulfide. Okay, let's try another one. So aluminum, so you use your periodic table and you locate aluminum. So aluminum is over here, and it has a charge of 3+. So I'm gonna write 3+ over here. Then you need chlorine, so chlorine is right here, and chlorine has a charge of 1-. So in order to balance out my charges, I'm going to need to add some more chlorines. So I add another chlorine atom, then that gives me 2-, but that's still not going to balance out that 3+, so I need to add another chlorine. So in total, my charge over here is 3-, and over here my charge is 3+, and that's what I want. I want them to have the same number, just opposite signs, and then I can use this information to get the chemical formula. So this means 1 aluminum, so I write Al, and I need 3 chlorines. So to show 3 chlorines, I write Cl3, and then the name, I start with my metal, aluminum chloride. Okay, all right, so we'll try one more example. If you want, at this point you can pause the video and then try to do the 3rd example on your own, and then press play and see if you got it right. Okay, so our final example, we're going to do calcium and fluorine. So again, you use your periodic table that I have attached. You locate calcium, calcium's right there. It has a charge of 2+. Then you use your periodic table. It's good to just leave it on your desk. It has a charge of 1-, it's right there. So 1-. So when I take a look at my charges, I can see that calcium is 2+, fluorine is 1-. So that means I need another fluorine. So my formula is CaF2, and the name is calcium. So the name of the metal doesn't change, and the non-metal, the ending changes to "ide", so calcium fluoride is the name of the compound.